Hello guys, welcome to NS Academy. So in this video, we're going to look at a problem from JEE Advanced 2024. So this was from JEE 2024, and this was I think problem one from paper one, and it's a very interesting problem actually because of the simplicity it bears. So this problem is a very common pattern or common type of problem that appears in many previous versions of JEE and in other exams as well. And here you can see. Let us read the problem once first. Let f of x be a continuously differentiable function. When we say continuously differentiable, it means that the function can be differentiated and all higher derivatives of this function exists. So basically, if you choose a positive integer n, then the derivative of fx done n times will also exist. That is what continuously differentiable means. And it is continuously differentiable on the interval 0 comma infinity, that is on the positive real line, such that f of 1 equals to 2, an information we would require later. And we are given that for each x greater than 0, this equation holds. So this is an equation involving limits and the function f of x and some polynomials t to the power n and x to the power n, x to the power 10, and we have to find f of x for all x greater than 0. Now, what I really wanted to show by choosing this problem is the pattern encoded in this kind of problems. So the limit we are given is simply this: limit t tends to x, t to the power 10 f of x minus x to the power 10 f of t divided by t to the power 9 minus x to the power 9 equals to 1. Correct? Now, this is very familiar to some standard limits that we already know. I will write down those two limits. So that is the first thing that should pop in your mind. That okay, so what can I relate it to? Obviously, if it's of the form 0 by 0, you can do Lapita and you can basically simplify it down. But what if you are not allowed to do that, or what if you do not know those advanced methods? Can you do it still using the methods that you have learned in class 11th and class 12 or your 11th and 12th grade? So the standard limit that basically falls in place is this: limit x tends to a, x to the power n minus a to the power n, my x minus a is basically equals to na to the power n minus 1. This is a limit that we will require because you see, why am I writing this limit? Why did this feel important here? Because of the pattern. We have a t to the power 9 minus x to the power 9. We also have t to the power 10 into something minus x to the power 10 into something. So this x to the power n minus a to the power n, this thing basically appears in the denominator, and it appears in a disguised way in the numerator as well. Also, this fact can be used, and if we cannot use it directly, we would find a way to use it indirectly. So how do we do that? So that is what I do in most of my problems. So you see there is a t to the power 10 f of x, right? But we don't need the f of x. How do we basically vanish it? Well, one way is to force it, which is we subtract from it something which has the term f of x, so that f of x can be factored out. And what we basically want is x to the power 10. So that when you factor out f of x, you basically get t to the power 10 minus x to the power 10, and that is something of the form x to the power n minus a to the power n, and the limit also supports it since it's t tends to x, as here it was x tends to a, right? But we cannot just introduce a term, we also need to add it to make things equal, like this, and then just write down the rest of the expression, and we should get something like t to the power 9 minus x to the power 9, and this is equals to 1. Okay. Okay, now we can use distributive law to separate these two parts of the limit because they exist independently, and we can do this, and we get limit t tends to x. Factor out f of x. In the numerator, write down t to the power 10 minus x to the power 10 as expected, and in the denominator, t to the power 9 minus x to the power 9. And then from this part, obviously we can take x to the power 10 common, but we would rather take minus x to the power 10 common, which also is outside the limit again, because x is not a limit variable, it's basically a constant in terms of the limit, which we can also do for f of x. In the next step, we will do that. Limit t tends to x, and we have f of t minus f of x divided by t to the power 9 minus x to the power 9 equals to 1. Okay. So we factor out f of x here, and now this part in the limit, this is reminiscent of the one we did here, the standard limit, but something is missing, right? So the x minus a factor is missing. How do we get that? Well, we can obviously divide numerator and denominator by x minus a, which in this case is basically t minus x. And remember the basic fundamental of limits, we can do that because t minus x, even though t tends to x, t minus x is not 0 because t tends to x. That means t is never equal to x. It's infinitely closer, but it's never equal. Okay, so when we divide up and down by t minus x, we can simply write this as the quotient of two different limits like this by t minus x and then minus x to the power 10. And similarly here we divide up and down by t minus x. We get f of t minus f of x divided by t minus x. And in the denominator we get limit t tends to x f of not f of t, this was t to the power 9 minus x to the power 9 by t minus x, right? And equals to 1. Okay, so using our formula, we get this one as equals to f of x into 10x to the power 9. And this one is 9x to the power 8 minus x to the power 10 multiplied by, you can see this is basically the definition of derivatives, right? The rate of change of a function. So f of t minus f of x by t minus x as t tends to x is simply the derivative of f of x. So it's basically f dashed of x, the derivative of f at the point x. And divided by, we have the same formula applied again, 9x to the power 8. And we have equals to 1. Okay, so we can basically cut off x to the power 8 and x to the power 9 here to get x. Similarly here x to the power 8 and x to the power 10 to get x squared. And what we basically have here after all is 10x by 9 f of x minus x squared by 9 f dashed x equals to 1. Okay, now we want to make the leading term of the leading coefficient of f dash x as 1, so that we have it in a linear differential equation format, because you can see it's a linear differential equation and we would need an integrating factor to easily solve it. So we multiply both sides by minus 9 by x square, so that you know the reciprocal of this basically, so that it becomes 1. So obviously this becomes 1, that coefficient of f dash x. But what happens to this? 10x by 9, I have already introduced a minus sign because we are multiplying by minus 9 by x square, and we have 9 by x square, right? And then we have f of x, and then we have minus 9 by x square. Okay, simplify this, x and x goes off, and 9 and 9 goes off, you have an x left over. So you basically have the equation f dash x minus 10 by x f of x equals to minus 9 by x square. Okay. Now it's simply left to do find the integrating factor. We know the integrating factor is simply e to the power p dx, right? Where p is the coefficient of f of x. So it's basically minus 10 by x. Now what is this? This should basically be 10 ln of x, which you can write as e to the power ln of x to the power minus 10, because the coefficient goes inside the log. And since ln also has base e, this is simply x to the power minus 10. So we multiply both sides by x to the power minus 10, and we see x to the power minus 10 into f dashed of x minus 10. This was already an x to the power minus 1, so we just multiply x to the power minus 10 to that, and we get x to the power minus 11 f of x is equals to minus 9 by x square into x to the power minus 10. Okay, you can see this is basically d dx of f of x into x to the power minus 10, correct? And this one it becomes, I think, minus 9 into x to the power minus 12. Okay, now we integrate both sides, we get f of x divided by x to the power 10, and remember that x greater than 0, so all of this makes sense, is equals to minus 9 integration of x to the power minus 12 dx. Now okay, so according to the, this is one of the simplest integrations obviously, and this would simply give you x to the power minus 11, I guess, by minus 11. Okay, and there would be a plus c, you would get f of x by x to the power 10 equals to, so the minuses will cut off. It will have 9 by 11 x to the power 11 plus c. Correct. Now we were also given the information that f of 1 equals to 2. We can put this in this equation to get 2 by 1 to the power 10 by 9 by 11 plus c, which should give us c equals to 2 minus 9 by 11, which is 22 minus 9, which is 13 by 11, right? 13 by 11. Therefore, f of x simply turns out to be x to the power 10 whole into 9 by 11 x to the power 11, and c is how much? 13 by 11, right? 13 by 11. Multiply this and you get 9 by 11x plus 13 by 11 x to the power 10, which is our answer for f of x. Now let's go back and see which one matches our answer. So 9 by 11x and 13 by 11 x to the power 10. So option B is the correct answer. So as you can see, this kind of questions, when you are doing it mentally, you are basically trying to speed run it. You are like, okay, so this is there, this is there. I can do this step. You know, this step should come immediately to your mind. So if not, you just remember this step from now on and try to apply it in situations where you see this kind of things are happening, to add and subtract something which would make the sum particularly easier. So once you arrive at this equation, this differential equation, then it's not so much hard again, because then it's basically the simple formula. So you can afford like 4 minutes, 3 to 4 minutes for a problem like this. And once you get better and better, you would require much less time. But then again, obviously, you could have done Lapita if you would have known that. And Lapita would simply give you the differentiation of top and bottom. And if you differentiate the top side, you get 10t to the power 9 f of x minus, and then f dash t x to the power 10. And denominator would have got you, I think, 9t to the power 8, right? And then you just put, because since now this would give you one, put x equals to 9, this would not give you a 0 by 0 form. You can simply put the value of x, and this would give you 10x to the power 9 f of x minus f dash x into x to the power 10, and this whole thing would be divided by 9x to the power 8, right? And then you could get the differential equation directly from there. So these are the two ways you can solve it. So Lapita is something I do not really want to cover in this video, which is why I have not stressed on this, but I wanted to show the basic way to do this. And Lapita is obviously a easier way to solve this kind of problems. But okay, then if it was a subjective problem, I think you have to basically state the Lapidus theorem, because you cannot use a theorem without stating it in any higher exam, which is subjective. Anyway, so hope you like this video. Let me know if there is something else that you would like to see.